So, plate tectonics. In geological terms, a plate is a large rigid slab of solid rock. The word tectonics comes from the Greek word to build. Putting these two words together, we get the term plate tectonics, which refers to how the Earth's surface is built of plates. The theory of plate tectonics states that the Earth's outermost layer is fragmented into a dozen of more large and small plates that are moving relative to one another as they ride atop hotter, more mobile material. A tectonic plate, also called lithospherical plate, is a massive, irregularly shaped slab of solid rock, generally composed of both continental and oceanic lithosphere. Plate size can vary greatly from a few hundred to thousands of kilometers across the Pacific and Antarctic plates among the largest. Plate thickness also varies greatly, ranging from less than 15 km for young oceanic lithosphere to about 100 km or more for the ancient continental lithosphere. The lithosphere is broken up into tectonic plates. There are currently 7 or 8 major, depending on how they are defined, and many minor plates. The lithospheric plates ride on the asthenosphere. These plates move in relation to one another. Earthquakes, volcanic activity, mountain building, and oceanic trench formation occur along these plate boundaries. The lateral relative movement of the plates typically varies from 0 to 100 mm annually. Continental drift. Continental drift is the movement of the Earth's continent relative to each other. The hypothesis that continents drift was first put forward by Abraham Ortelius in 1596 and was fully developed by Alfred Wegener in 1912. However, it was not until the development of the theory of plate tectonics in 1960s that a sufficient geological explanation of that movement was found. Alfred Wegener contended that around 200 million years ago, the supercontinent Pangaea began to split apart. Alexander Dudoit, professor of geology at Johannesburg University and one of the Wegener's Stone Age supporters, proposed that Pangaea first broke into two large continental land masses, Laurasia in the northern hemisphere and Gondoaland in the southern hemisphere. Laurasia and Gondoaland then continued to break apart in the various smaller continents that exist today. Wegener's theory was based in part on what appeared to him to be remarkable feat of the South American and African continents. Wegener was also intrigued by the occurrence of unusual geologic structures and of plant and animal fossils found on the matching coastlines of South America and Africa, which are now widely separated by the Atlantic Ocean. He reasoned that it was physically impossible for most of these organisms to have swum or have been transported across the vast oceans. To him, the presence of identical fossil species along the coastal parts of Africa and South America was the most compelling evidence that the two continents were once joined. In Wegener's mind, the drifting of continents after the breakup of the Pangaea explained not only the matching fossil occurrences but also the evidence of dramatic climatic change on some continents. For example, the discovery of fossils of tropical plants in the form of coal deposits in Antarctica led to the conclusion that this frozen land previously must have been situated closer to the equator in a more temperate climate where lush, swampy vegetation could grow. Other mismatches of geology and climate included distinctive fossil forms, glosso, glossopteris, discovered in now a polar region, and the occurrence of glacial deposition present day in Africa, such as a Vaal River Valley of the South Africa. A fatal weakness in Wagner's theory was that it could not satisfactorily answer the most fundamental question raised by his critics. What kind of forces should what kind of forces could be strong enough to move such large masses of solid rock over such great distance? Wagner suggests that the continents simply flowed through the ocean floor, but Harold Jeffreys, a noted English geophysicist, argued correctly that it was physically impossible for a large mass of solid rock to flow through the ocean floor without breaking up. Mid-oceanic ridges. Before the 19th century, the depth of the open ocean were largely a matter of speculation, and most people thought that the ocean floor was relatively flat and featureless. However, as early as the 16th century, a few intrepid navigators, by taking soundings with high end lines, found that the open ocean can differ considerably in depth, showing that the ocean floor was not as flat as generally believed. It was very much roughed. All along the globe, a system of mid-oceanic ridges was detected. An important conclusion was that along this system, a new ocean floor was being created. In 1961, scientists began to uh, theorize that mid-ocean ridge marked structurally weak zones, whereas the ocean floor was being ripped into lengthwise along the ridge crest. New magma from deep within the earth rises easily through these weak zones and eventually erupts along the crest of the ridge to create new oceanic troughs. This process, later called seafloor spreading, operating over many millions of years, has built then a 50,000 kilometer long system of mid-oceanic ridges. Um, uh, there are There are three types of plate boundaries: divergent boundaries, convergent boundaries, transform boundaries. Divergent boundaries, where new cross is generated as the plates pull away from each other. Convergent boundaries, where cross is destroyed as one plate dives under another, under under another. Transform boundaries, where crust is neither produced nor destroyed as a plane plates slide horizontally past each other. So this is a formation how it becomes. So you can see here. So let's see again. So there was this was this was a single plate Pangea. Let's say a single continent Pangea, and it get divided into number of continent like this, and this become our today's art. Oh, the Everest Peak of Nepal. The Everest Peak, the highest point on Earth. Around 400 million years ago, the area was under the sea. How Himalaya are formed? Himalaya is the product of collision between Indian and Eurasian plates. So this was the content for today. So thank you.